carbohydrates. These are the most abundant organic molecules in nature, and we know that these carbohydrates, they are the source of energy. When we take the food which has carbohydrates, it gives us energy, and they are primarily composed of elements like carbon, hydrogen and oxygen. And we call these carbohydrates as polyhydroxyaldehydes or ketones. Why? Because it has, poly means many, and hydroxy, it has a OH functional group. So it has many hydroxy groups, and it can be aldehyde or it can be ketone. And these carbohydrates, they are primarily produced by the plants and form a large group of naturally occurring organic substances like cane sugar, glucose, starch, etc. So we'll start with the classification of carbohydrates. It's broadly, these carbohydrates, they are broadly classified into 4 groups. First one is the monosaccharides, then disaccharides, then oligosaccharides and polysaccharides. So what are monosaccharides? Mono means one or single, and saccharides, it means sugar. So monosaccharides, they are often called as the simple sugars because they have only one sugar moiety, and which possesses a free aldehyde or ketone, and it has more than 2 hydroxy groups. That's why we call them polyhydroxyaldehydes or ketones. And these monosaccharides, or we can simply call them simple sugars, they can be subdivided into, based on the number of carbons, we can call them trioses. Tri means 3. Similarly, tetroses or pentoses and hexoses, right? And depending upon the number of carbons, we can name them accordingly. And depending on the functional group present on it, whether it's aldehyde or ketone, we can call them aldotriose, means it has an aldehyde group, and triose means it has 3 carbon. And similarly, ketotriose or aldotetrose, ketotetrose, and so on and so forth. So this is the first classification, that is the monosaccharides. Mono means single, and it's a simple sugars, and it's subdivided into different categories based on the number of carbons, right? Then these are some few examples of trioses, tetroses. Like in triose, we have the both aldo sugar, we can have the keto sugar, like glycerose, it is an aldose, or it is an triose, right? And it has an aldehyde group, so it comes under the aldose. Similarly, erythrose, ribose, glucose, we know hexose, because glucose, obviously when carbohydrates break, we will see in the coming slides that when carbohydrate breaks during glycolysis, it breaks into the glucose, which gives us energy, right? So glucose, its formula is C6H12O6, and it is the it comes under the hexose category, right? Then these glucose, they can exist in either this acyclic structure or cyclic, but most of the times the glucose or any sugar, for example, they exist in the cyclic form. And here we are showing that how this cyclic form is formed. So here we have this D-fructose, right? Then we have this OH group in the blue. It has this oxygen which is nucleophilic, and we have this carbon number 2, we have this ketone, and this carbon is electrophilic. Why? Because it has an oxygen attached to it, and it is electrophilic because oxygen is withdrawing electron density, making this carbon electrophilic. So there is here we can see this oxygen, the lone pairs on the oxygen acting as a nucleophile, they are attacking on this carbon, and this cyclic form of the any sugar moiety is formed. For example, here it is shown as the glucose, fructose, the cyclic form of fructose,